Good morning students. Welcome to our new class, and today we have to study how can we derive the derivation for escape velocity. In previous class, what is escape velocity? That concept that was understood by us, and today the derivation of the escape velocity that we have to derive. So to find out the derivation of escape velocity, we must have to know that on the earth surface any body or object may have two types of energy. The first one is kinetic energy. The general formula is half mv square. Another type of energy that a body can possess, that is potential energy, and the formula is minus gmm upon r. And we have to find out the sum of these two energies. So the total energy is equals to sum of these two energies, that is half mv square minus gmm upon r. So the same thing if we apply on another case, that is at the infinite distance from the earth. So at that point in space, kinetic energy equals to 0. The formula of potential energy is still same, minus gmm upon r, but at infinite distance r is nothing but the infinite distance, so it is infinity. Any number upon infinity, that is 0. It is not infinity, the answer is 0. So the total energy of both these two types of energy will become 0. So by principle of conservation of energy, these two energies are equal because the total energy remains constant. So on the basis of this principle, this term, equation 1 equals to 0, this term equals to 0. So this term is shifted to another side, this one. Get cancelled on both sides. We remain v square upon 2 equals to g capital M upon r. To find out the velocity, v square remains as it is here and u is transferred to another side. To find out the expression for v, we have to remove that square. For this we have to put up the square root on another side. So v equals to under root twice gm upon r. This is the formula for escape velocity. Yes, escape velocity. In another terms, in the form of gravity small g, this formula can also be written in the form of under root twice gr. If we substitute the value of capital G, 6.673 into 10 power minus 11 Newton meter square per kg square, and the mass of the earth m, that is 6 into 10 power 24 kg, and r, that is the radius of the earth, it is 6.4 into 10 power 6 meter, or in case roughly 6400 kilometer. So if we put up this value, we will get the value of maximum or the velocity that is required to escape from the gravitational force, that is 9.2 kilometer per second. Or we can also calculate this formula or this value by the help of another formula, that is under root twice gr. If we put the value of gravity and if we put the value of r, that is radius, so we can also get the same value by this formula also. So this is the general way to find out the escape velocity. I hope you must well understood that particular derivation of escape velocity. Thank you. Jai Hind, Jai Bharat.